Hey, welcome back, everybody. This is going to be we're going to wrap up 8.3 with this. This will be part 2 of Infinite Geometric Series, and I want to get right to work and show you what I've done. Okay, so we've got the final parts of our notes. Oh, wrong page. That is the formula sheet. Okay, so now here's our notes. It says if r is greater than 1, the series diverges. Well, okay. Notice that I'm not being asked to sum this to infinity because I can't. So in other words, this problem is one we've already done. We're just going to take this thing. It says find the sum of the first 10 terms. Well, that's why I had this open. That is this formula. The 10th partial sum is what they want. So that's the difference. You know, they're not asking for infinity. We can't give it to them anyway because it's an infinitely large number. And now we can just compute this using a couple of things. Use the formula, or you can just use your calculator. I want to show this one more time to show you how this can be done with a calculator. But the first thing you got to find is, what is A? Well, it's 1. R is 3 halves divided by 1, which is 3 halves. So it's pretty simple. So you're going to use your geometric sequence formula and sum it up. So we'll say math 0. We're going to sum this thing up. So we're going to start at 1. And we're going to sum up to 10. And we want to sum 3 halves. I'm not putting A in there because A is 1. And that's just, and this is your geometric sequence formula. And you get 113.33 roughly. So what we would say is this is approximately, I don't know, 113.33. Okay. So one more thing, you know how I like to do this in class. There is one more problem I wanted to talk about. This is find the sum, and it gives me, and it's not necessarily geometric either, it's just a random problem I found. And I haven't done one like this with you. It said, they want me to sum this thing up, and they give me a series. They don't tell me the type, so we need to find out what type it is, and then we'll figure out what we can do here. I guess a really quick inspection here, it looks like it's arithmetic. 13, 16 is going up by 3. It's got a common difference of 3 in the first term of 10. Okay, so what we want to do, we don't know what n is to do this sum. We don't know what term, what value of n this is to use our formula, or our summation, or whatever we're going to use, or the formula from the AFM sheet. So what we can do here is write an equation. Let's see, we know this. We know that 52 is equal to 10 plus the common difference times n minus 1. And that means that 52 is equal to what? Okay, 3n plus 7. And when we solve that for n, we get n is 15. So I'm just going to space over. So n is 15. Now we can use our sum and add this thing up. Okay, let me go to the sum. Clear this guy out. Math sum. All right, we're going to start this thing at 1. We're going to add up to 15 terms. And we're going to add 10 plus, no, what was it? We did better than that, didn't we? Didn't we have 3n? Come on. 3n plus 7. So it sums up to 465. So the answer is 465. So that's how you would do that one. I hope you found this video helpful. And the next thing we got to start working on is going to be binomial theorem. It's a little tricky. It's going to take several videos to get through that, and hope to see you there. And don't forget to check in with me in the afternoons at 1:30, and we'll have a conference, and any kind of problems you're having with this that you don't understand, I'll be more than happy to give you a heads up on how to handle the problems. And you know, sometimes you guys discover things that I haven't found, new ways to do stuff. I always like that. You know, there's not always one way to do things. So I'll see you in the next video. Stay healthy. Be careful out there.